Okay, so far in Python, up until using what we call control structures, your code just kind of follows this linear in order path. So if I have this graph code here, we print hello world, we ask for an integer, we print out what that number was, we double it and we add 10 to it and we print out the new number. So this is all we've done so far, is just go in order by each line. But we can introduce control structures, which are going to be what we call if statements, loops, and different logic types to say whether or not to do something, how many times to do a bit of code, and whether or not to skip something too. So in order to do that, we first need to look at some logical, what we call logical operators. So if you remember, we have Boolean variables, right? So if I say apple equals true, I can print apple, right? Apple prints out as true. If I change this to false, Apple will print out as false. Okay. So we can get these statements in different ways, right? So let's say this is a string to 4. We can check, if you remember from string methods, if apple is a digit, right? So this returns true, right? There we go. We get our true. So we can get this stuff by methods, or we can use logical operators. So if I say apple equals true, let's say true, and banana equals false. That's spelled wrong. Okay, anyway. What we can do is compare the two of these. So I can say, is apple and banana this is asking, when you look at both sides of an and, both of them need to be true. So this is saying, is apple and banana true? Apple is true, but banana is false. So we print false. But what if I change this to an or? Now we get true. I'm annoyed at that thing, so I'm just gonna hit break. No, that doesn't work. Oh, right, I need a breakpoint. So if I do something like this, I gotta double click somewhere. Okay. Whatever, not worth it. So, and or, right? Both sides aren't true, so it's false. Or it just needs one side to be true. So that is true again. Let's add something else in. Let's go mango now. We go banana. This works the same, only one of these needs to be true. What if we need apple? You know, I'm going to move this around. We need apple and mango or banana. There's different rules like how PEMDAS works as to how this is going to work. So ors precede over ands. So first it's going to do this and statement, then it's going to do this or statement. So banana is false, but both apple and mango are true. But if I change one of these to false, this is going to make this false and that part false. So everything's going to pop out false now. So that's how and or ors work. When you're looking at something like numbers, 10, 15, 16, okay, print, we can check if apple is less than banana. That's true. Less than or equal to, this should also be true. Okay, greater than or equal to, that's false, and greater than would also be false. So now what we can do is, so that's all for greater than, less than, and so forth. If I go back to, or actually we can leave them like this, but if I want to see if two things are equal, if I want a Boolean thing, I can't do this, right? I can't say apple equals banana because that's how you assign a value. So if you're checking if something is equal to, it's two equal signs. So it's very important. This is equal to, and it's a Boolean statement to see if something is true. So apple does not equal banana. If I put it at 10, stop and rerun, now this pops up as true. Apple is equal to banana. Now, I can check one more thing. Instead of is equal to, I can check is not equal to. So this exclamation point means not and reverses whatever we put here. So you don't need a double equal sign for is not though. So this is true because apple is 10, banana is 15. If I put this though, now this will pop up as false. All right. This not operator will also work to reverse anything. So if I print apple, right, apple shows up as true because I set it as true. But I can reverse it and put an exclamation point here. Print not apple. Except it's getting mad at me for some reason. Okay, let's make a new Boolean. Orange is going to equal not apple. Why won't it let me? Is this exclamation point? Okay, so that exclamation point is actually for Java code. So don't worry about that. Instead, you would just write not apple, and that would reverse everything. So now, even though apple says true, we're going to say it's false once we use the keyword not. All right, so that should be all the important operators for this. I'll write them. Actually, I'm going to write them out quick just to go over again quickly. So we have and, both sides must be true. We have or, one side must be, at least one side must be true. At least one side must be true. We have not, which reverses Boolean, true to false and false to true. We have less than, or less or equal, greater, and this one is greater than or equal. I forgot these little dashes, don't want to make anything confusing. So less than, what was I missing? Oh, that is equal to. And then exclamation point that is does not equal. The exclamation point is still for this does not equal, but when you're looking at a Boolean statement, you would just use not. So let's say I want to run this program for real this time. We want to not do all these steps. We're going to enter an integer, okay? And then based on that integer, we're going to do different things. So let's say we only want to double the integer if it's less than 12, okay? So if x is less than 12, well, you know what? First, we're going to print x less than 12, all right? So if I put in 11, your number is 11. This statement is true. X is less than 12. So we can ask a program keyword if X is less than 12, all right? We're gonna double it. All right, let's comment out this part for now. So now we're just looking, is X less than 12? We're gonna double it. So 30 doesn't do it. It only will do it if I enter something less than 12. Now my new number is 10. So that's if. Now let's say I want to do something, we want something else. So if X is less than 8, all right, then we're going to run X plus equals 10. So if I run something like 11, we're just going to double it. Okay, so the code's coming down here, X is less than 12, double it. Now we're asking, is X less than 8? Then we add, it's not, so we skip over this part and just print out our new thing. But if I put in 7, the new number is 14. Oh, okay, so this actually isn't working the way I thought it was because I'm using X times equals. So 7 becomes 14, and that's not less than 8. So why don't I run this and do 2? So 2 times 4, 2 times 2 is 4, and that is still less than 8. So it doesn't skip this and adds 10. All right, so that's how the if statement works. There are multiple parts of this if statement though. So if I don't want both of these to run, I want them to be mutually exclusive, I can just write else. If the number is less than 12, we're gonna double it. Otherwise, we're gonna add 10. So if I put in 11, our new number is 22. But if I put in 12, it's not less than 12. We add 10 to get to 22. This will change if I use this less than or equal though, right? So if I put in 12 now it just doubles it to 24. So that's how if else works. There's one more thing that comes with an if statement though. We can do elif or else if. So this is gonna add another statement. So we can add X is less than 15, all right? X plus times equals 3, okay? So before, the big difference with this is before, I'm going a lot back, I just realized, but before we had, okay, this isn't working. Anyway, when we had this, the computer is asking, the program is asking both is X less than 12, then it's asking if X is less than 8. But if I change this to elif, it's only going to ask, is X less than 15 if X is less than 12 isn't true. So it's gonna skip this once one of these statements get made. You can have unlimited elifs, but once one of them gets made, it's gonna go right down outside of the control structure. And then you can end with an else, which is if all the ifs and elifs are true, you're gonna do something. So we can also have elif X is greater than 100. X is gonna be minus equals 50. This colon is important, I forgot. So we're gonna ask, we're gonna enter a number X. If it's less than 12, we do times equals 2 and skip down to here. If it's greater than 12, we're gonna ask, is it less than 15? If it is, we add 10 and skip down to here. If both of these are false, we're gonna continue. If X is greater than 100, then we subtract 50 and skip out here. If all three things of these are false, then we're gonna do this. So we can play around and then there's some numbers. 13 does add 10. I put in 5, it does just double it. I put in 75, that just multiplies it by 3. If I put in 125, it goes down to 75. So that's the gist of the control structure for if statements using, if something is true or false. Now, if I want to use an and statement in here, we can put back in my apple equals true. Okay, so we're only going to do this if x is less than 12 and apple. So that's saying if both of these are true, we run this. So that's how that works before. So I can put 5 and my number is 5. But if I switch this around to false, right, we're going to skip out of here. We're going to look less than 12 and just do less than 15. So this will also, we can reverse this by doing and not apple, right? Now if I enter 12, or if I enter 10, that doubles it because this part is true, 10 is less than 12, and not apple, the reverse of false is also true. So both sides of this are true and we double it. Okay. So using a different type. So if we're looking at something a bit more complex, we'd have this ice cream shop, right? So we have these symbolic constants where the price of chocolate, vanilla, and twist is defined. The price of a waffle and bowl is defined, and a scoop dictionary is defined to easily convert prices from scoops. So 1 scoop costs 50 cents, 2 scoops cost 1 cent, 3 scoops cost 1.25. Okay. So we're gonna have them enter all this stuff. So we have them enter. So when we run this program as is, we enter, okay, we want chocolate, we want 3 scoops, and we want waffle, okay? And then we have a bill where we're gonna add in the prices here and the total, okay? So the way we do this is we need if statements now based on what they entered. So we want them to enter just C, B, or T for the flavor. So if flavor is equal to C, right? We're going to take our price. We're going to plus equals the price of chocolate, okay? And we're going to set a new variable, a flavor price, so we can record that separately, just to be whatever chocolate was, okay? Now we'd go else if flavor is equal to vanilla, right? This is going to be the same thing. Price plus equals vanilla, and our flavor price is going to equal vanilla. Now, we can do 2 things here. We can do if the flavor is equal to twist, we would take price plus equals twist, and we'd make our flavor price equal to twist. Now we could also functionally use an else here and not include this statement because this is the last part. There's only 3 options, but elif is more accurate because what if someone enters something that isn't chocolate, vanilla, or twist? We don't want to set the price to something it's not. So there we go with that. Now we're going to see how many scoops they would like. We actually don't really need to do anything here. So we could do our price is just going to be plus equal. We'll use the dictionary, the scoop dictionary, right? So if they entered however many scoops. So let's, for now, actually just print out however many scoops. Oops. Scoops. Okay. So right now, when we run this, okay, if I put in twist, put in 2 scoops, we're looking at how many scoops, right? So I put in 2, and that converted to $1. So we're automatically doing this conversion, so we don't really need a control structure here. So anyway, I can just take my price and plus equals the scoop dictionary of however many scoops they entered. We just put in this, whatever they entered as the key. And we're going to set our scoop price. It's going to equal the same thing, whatever this was. Now, instead of doing this, like this, right? I can reverse this order now that I think about it. And then instead of writing out the code twice, I can just do plus equals scoop price. So here, I can do my price is equal to the plus equals the flavor price. And then I can do fewer things per line, right? All I need to do is enter this control structure. If it's C, we're going to set our flavor price, set our flavor price to vanilla, our flavor price to twist, and then we just plus equals by the entire flavor price. So this is going to be add flavor price to running total, calculate flavor cost, calculate scoop cost, and this is going to be add scoop price to running total. Okay. Now we have one more thing. Which would you like, a waffle or a cone? So if these ifs and elifs, right? If it's not chocolate, it's going to go to vanilla. It's going to go to twist. We could also just ask, we don't have to do it all blocked off. We could just do if. So that's what I'll do for the dishes. But you got to be careful though when you're using multiple ifs, because it's going to ask the question twice. So since all these options are mutually exclusive, you can just ask if. But if they weren't, if something could be equal to chocolate and be equal to chocolate again, you'd have to do if and elif. So anyway, we'll do if dish is equal to waffle, if dish is equal to bowl. So you notice I have these on this part. So the next line has to be indented. And we're going to set our dish price. It's going to equal waffle. Put calculate dish cost here. Bowl, our dish price, is going to equal bowl. And then we just add it to the running total. So price plus equals whatever our dish price is. Okay, now we're down here. To running total. Okay, so now we're just going to put in our prices. So flavor price. We're going to put this left aligned 5 spaces, that 2F. Don't forget my $sign. Okay, so $, scoop price, left aligned in 5 spaces. I'm going to put this $, dish price, left aligned 5 spaces. And then our total price is going to be just our price. Price, left aligned again to 5 spaces. Now I can put chocolate, 2 scoops in a bowl. Dish price is not defined. Okay, this is supposed to be just equal. Oops. Chocolate, 2, bowl. So 2 plus 1 plus 50 cents is going to be $3.50. Let's do 4 and add a space everywhere. Noah, 3 scoops, a waffle cone. So 1 plus 125 plus 1 is 325. I can also just print an extra space here. Twist, 1, waffle. So we're asking all these different things, getting different values and summing them differently. So if I look at what I just did, we entered if the flavor is equal to twist, We set the flavor price to twist, increased it. Then we just increased it by the scoops. We said 3 scoops. So that's how we got to 50 cents because I entered 1 scoop. And then a waffle cone. You put this as bowl. So you got to be careful also. Like I set these all as capitals. That's because if you look up here, I made both these automatically go to dot upper. So I always like to do this on the input because that way you know what you're working with throughout. But you might have to account for it in the if statements and check if the dish dot upper is equal to W and so forth. So hopefully this helps you get started using if statements and control structures. The next video will be on loops, which will be repeating stuff.